Hello everyone, today we're talking about lesson 10.1, circles and circumference. Our first objective will be to identify and use parts of circles. Our second objective will be to solve problems involving the circumference of a circle. So, definition here. A circle is the set of all points in a plane equidistant from a given point called the center. So, each point on the circle here is equidistant from the center of the circle, which in this case, this example would be C. Little notation, we use circle C, or we can just put a circle C, and that's how we can name our circles. So let's get into a few more definitions here. So these next three. A segment with its endpoints at the center and on the circle is called the radius. This is the segment that we're describing here would be called the radius. And let's go over here to the next slide here, and let's draw a radius. So if we've got a center of the circle, in fact, I'm going to use a tool here to do this. Let's use a line. Let's use a line. Let's go from center to the edge of the circle. Again, a radius has endpoints at the center, so one of the endpoints of that radius would be here in the center. Let's call it C. And then the other endpoint would be on the circle. So some point over here that is on the circle. And we could draw a radius any point from the center to the circle. Okay? And so on the previous page, if we look at back here at page 1, the next definition would be a chord. And a chord is a segment with endpoints on the circle. So let's go back here to our circle, and let's do our best here to draw a chord. Again, I'll use the line. And again, just endpoints on the circle. So start with an endpoint on the circle, go to any other point. I could go over here. That'd be an endpoint on the circle. I could go this direction. That would be on the circle. I could go through the center. That's going to come up here. I could go somewhere over here. So any of these examples would work for a chord. This is a chord I've drawn here. And then lastly, if we go back here to page 1 again, the last definition would be a segment that is a chord and includes the center. So and includes the center of the circle is called a diameter. So a diameter is just a chord that also goes through the center. So I'm back here on my circle. I need a chord, so it's got to have endpoints on the circle. So let's just start here again, and this one should actually go through the center of the circle. So it should go through point C, and that chord goes through the center of the circle. All right, so those are the three definitions there from page 1, and we've got examples of each of those. Again, a chord is just a segment. So this one is our example for chord. Just has endpoints on the circle. The radius here, the radius from the center to the edge of the circle, and then the diameter, of course, was that last one. We just endpoints on the circle, goes through the center. All right. So those are examples. We'll go back to the full screen. All right. And so let's talk then, identify segments in a circle. Name the circle and identify a radius. So here in part A, well, the circle, and we call it by its center point. So circle P, example A. And we want to identify a radius. I can see 3 radii that we could identify. The first, again, all radius, they they start at the center. So I'm going to make a list of all of them. So we call these radii. So any segment that starts at the center and goes to a point on the circle. So PL would be a radius. PN would be a radius. So we can use blue to highlight that. PN is a radius. And lastly, PM would also be a radius. So there's 3 radii we've identified. PM, PN, and PL. All right. Just as a quick quiz, I know the question doesn't ask this, but what would segment MN, what would we identify MN as? Think about that for a second. All right, if you said chord, that would be correct. Segment MN identifies that would be a chord with segments on the circle, or endpoints, excuse me, on the circle. All right, so here, problem B, we've got identify a chord and a diameter of the circle. So again, there's 2 chords I see here. So chord, identify a chord again. A chord is just a segment with endpoints on the circle. So certainly JK would work. Okay, it's got endpoints on the circle. HG also has segments, endpoints on the circle. So what makes HG different than JK? Well, JK is also, HG is also what we call a diameter. Why is that? Well, HG goes through the center of the circle, so HG is also a diameter. Right? Continue here. Radius and diameter relationships. If a circle has radius r and diameter d, the following relationships are true. Radius is equal to 1/2 the diameter, or diameter divided by 2. And for diameter, diameter is just equal to 2 times the radius. So example 2, let's apply that relationship here in example 2. If QV is 8 inches, so QV is a radius of the circle, Q. What is diameter of Q? So again, use the fact that diameter is 2 times the radius here. Well, QV is a radius, so diameter is 2 times 8. So here, diameter is 2 times 8 is 16 inches. Okay, if we're given units, we need to make sure we stay in our units. We're given inches, so 16 inches. Okay. Circle pairs. So 2 circles are congruent, and if and only if they have congruent radii. And all circles are similar. Concentric circles are coplanar circles that have the same center. So those are types of circle pairs we can identify. Kind of concentric circles. Just think of targets here. Think of the Target logo, even in Target stores. Just concentric circles. They have the same center point, but they are of different size. Okay. Here on the next, we've got how circles could intersect. A couple of examples of 2 points of intersection. All right. Kind of looking like a Venn diagram there. 1 point of intersection, they could either intersect on the edge there, here. And then no points of intersection, just circles that are drawn independently, or concentric circles would intersect. So that's how circles intersect. All right. Find measures in intersecting circles. All right, so this next example, we're going to find some measures in some intersecting circles. Okay, clearly these circles intersect at 2 points. All right, so diameter of circle S is 30 units. Okay, diameter of circle S is 30 units. The diameter of R is 20 units. And DS is 9 units. Find CD. DS. It's 9 units we are looking for. CD. All right. Well, what can we do? So what would the radius of S be? If the diameter of S is 30, then the radius of circle S would be half the diameter, so half of 30 would be 15 units. So radius of S is 15 units. Let me highlight what a radius of S is. So use another color here. So a radius of S, of circle S, would be what I've highlighted there in green. So CS, the segment CS, that's a radius, would be 15 units. We just found what the radius would be. Okay. On segment CS, we have point B, and we know that this was given to us in the problem that DS is 9. So could we find CB just using a little bit of addition, subtraction? Certainly. Okay. 15, the whole radius minus the segment SD or DS would be equal to CB. So 15 minus 9, which is 6, would be equal to CB. Okay. And let's continue on here. Just give me one moment. Yeah, we're about at 12 minutes. So yeah, this will be a good stopping point here. Let's go ahead. Let's make the 10.1. Let's make this part 1. 10.1 part 1. Let's go to page 701, 10 through 21. All of them. That'll be a good stopping point for today. You guys can do that as your assignment. We'll continue on with 10.1 in another video and finish up some stuff.